Okay, on this next part of the notes, we're going to address multiplying two polynomials. So we've just reviewed adding and subtracting polynomials. Now we're dealing with multiplying polynomials. Now, we've dealt with multiplying polynomials before, and we're most accustomed to seeing this in a horizontal format when they're side by side. The first thing I'm going to address, though, however, is multiplying polynomials in a vertical format. And so you can see example 3, we have these polynomials stacked on top of each other. Let me go back to a time when you learned how to do multiplication, probably back in 3rd, 4th, and even 5th grade, where you learned how to do long multiplication. And so let's just take the example 125 times 11. And if you recall, you take the first value and you multiply it times every value on top, giving you 125. Now, the next step is an important step in recalling. You did one of two things. You either left a placeholder blank, or some of your teachers may have taught you to put a value of 0 as a placeholder, and then at that point you multiplied the second number to everything. So 1 times 5 times 2, and so we get 125. And in effect, that 0 shifted everything to the left. And then at this point, we were to add these two numbers. And so we have 5 and 7, 3 and 1. And we come up with our final answer with long multiplication. Well, in essence, when we multiply polynomials in a vertical method like this, where we stack them on top of each other, we do the exact same thing. Here in our example 3, you can see we start with the first term, -3. So we're going to multiply the first term of -3 times every value on top. So -3 times 4 is -12. -3 times 2x is -6x. And -3 times x squared is -3x squared. Now, the next step is just like in 3rd grade. You have to hold it, that spot, with a 0. So now when I start multiplying the x to every value on top, what that does is it allows me to stack up the common like terms. So you can see that we have x's stacked on top of x's and x squareds stacked on top of x squareds. And this allows us to add these two parts together in a stacked form as well. So that 0 is a very important placeholder that needs to be put in if you're going to multiply polynomials in a vertical method. So go ahead and give that a try in sample problem number 3. See if you can multiply these two polynomials using a stacked form. Okay, so the first thing I'm going to do is I'm going to multiply the 1 times every term on the top. Now, fortunately for us, that's a pretty easy process because 1 times anything is itself. So we're going to be left with 4x squared plus x minus 5. Now, the next part, we have to create a placeholder of 0, and then I'll start multiplying 2x times everything. So 2x times -5 is -10x, and of course I want that to stack up with my x's. 2x times x is going to be a positive 2x squared, and so my x squareds are stacked up. And then 2x times 4x squared is going to give me 8x to the third. Don't forget your exponential properties. So when you're multiplying a variable times a variable, you add the exponent. So x times x squared is going to give us x to the third. And now that they're stacked on top of each other according to common terms, we just combine the like terms. So -5 is going to give us -9x, because that's an understood 1. It's going to give us positive 6x squared, and then 8x to the third. And there's our final answer, multiplying the polynomials in a vertical format. So just like your old 3rd and 4th grade multiplication, you can multiply polynomials the same way. Now, what most of y'all are probably more familiar with is in a horizontal format where they're side by side. Now, you're probably accustomed to having two binomials next to each other, and you would simply call this process FOIL. But you can see in example 4, we have a binomial and a trinomial next to each other, and so this is going to require us to distribute both individual parts. The word FOIL does not really work for us in this, and is not appropriate for us in this particular type of problem. So you can see in the example I've broken it up, but in essence all you're doing is you're distributing the x, or the first term, to everything, and that's going to be taken care of right there. In the second step, we're going to take the -3 and distribute to everything in the second term, and of course that's taken care of in the second step. And then once you've distributed everything, you can combine like terms and get your final answer. So distributive property, which is what FOIL is based off of, is really the method that you're going to be using here. So if you go down to sample problem number 4, go ahead and pause the video and use the distributive process to multiply these two polynomials. Okay, so the first thing I'm going to do is I'm going to take the x value and I'm going to distribute it to everything on both sides, across the second term. So x times 5x is 5x to the third. Remember your exponent properties. X times 3x is a positive 3x squared, and x times -1 is negative 1x. And if you don't want to write the -1 or the 1, that's fine. You could just write that as negative x. The second part of this is taking the 2 and distributing it to everything. So 2 times 5x gives me a positive 10x squared. 2 times 3x gives me a positive 6x. And then 2 times -1 gives me -2. And then now that we have distributed both parts, we just need to combine like terms. So that's going to leave us 5x to the third plus 13x squared plus 5x minus 2. And we've multiplied the polynomials in a horizontal format. Learn both ways and then just decide which one works best for you, and you can use that method on the test.